Now, along with absolute value equations, we also have absolute value inequalities. And in order to show you the relationship here, we're just going to use the same value, 3, 3, and 3, and use just separate inequalities. An equal, right, an equation, which is what we talked about how to do, greater than, and then a less than or equal to. So the first thing that you want to do is you want to solve it using an equation, and that will help you for your inequalities. So here we know that x is going to equal 3, oops, not negative 1, hello, 3 or negative 3. Okay, so what we can do for our inequalities is we can actually take these values, put them on a number line, 3 and negative 3, or negative 3 and positive 3. We're going to do that for each one of these. Negative 3 and positive 3. And we're going to look and say, okay, well, what region is going to make this true? But because there's an inequality symbol, it's not, because there's an absolute value symbol, it's not as easy as just looking at the inequality and plugging it in, like our previous inequalities, because there's an absolute value here. So another option is we can go ahead and just pick a number in each of your 3 regions, your left region, middle region, and right region, plug it in here and see if it'll make the inequality true or false. So I'm going to go ahead and pick negative 10, which is below negative 3. I'm going to pick 0, which is between negative 3 and positive 3. And I'm going to pick a positive 5, which is greater than 3. And I'm just going to substitute each of them individually. Okay, so if we plug in negative 10, so we're just going to check here. The absolute value of negative 10 is greater than 3. Well, the absolute value of negative 10 is positive 10, and is positive 10 greater than 3? Yes, it is. So we know that, okay, the left-hand region is going to work. We can generalize. Then we can do the same thing for 0. The absolute value of 0 is greater than 3. The absolute value of 0 is still 0. And is 0 greater than 3? No, it most definitely is not. So we know that that middle region is not going to work. And then we can go ahead and choose 5. So the absolute value of 5 is greater than 3. And is 5 greater than 3? Yes, that is. So we know that that's also going to be a solution. So if we look at this here, we know that everything to the left of negative 3 is a solution. We have a greater than symbol, right, versus greater than or equal to. So we're going to use a parentheses here. And then, oh boy, that's a big ugly parentheses. And then everything to the right of positive 3 is also going to work. So we can go ahead and use our shade our right-hand side and then use our parentheses again. So our solution to the inequality, the absolute value of x is greater than 3, is going to be these 2 regions, which if you recall, writing that in interval notation, is going to be negative infinity to negative 3, the union of that with positive 3 to positive infinity. Then we can go ahead and do the same thing here for the absolute value of x is less than or equal to 3, right? And it doesn't matter whether you have greater than, or equal to, less than, or equal to. Okay, that just changes the parentheses or brackets that we have there. Okay, so here again, we're going to go ahead and pick some values, and I'm just going to pick the same values because we already have the numbers for it. So we have the absolute value of negative 10 is less than or equal to 3. Is 10 less than or equal to 3? No, it's not. Okay. Then we have the absolute value of 0 is less than or equal to 3. Is 0 less than or equal to 3? Yes, it is. So this one's out. This one's good. And then 5, the absolute value of 5 is less than or equal to 3. Is 5 less than or equal to 3? No, that is not either. So here we just have this middle region. That's a solution. And because we have less than or equal to, we're going to have brackets on each end facing the shading, opening towards the shading. So that, as interval notation, would be from negative 3 to positive 3. Okay, and that's simply the relationship. Now, if you notice, you're either going to have the middle as a solution or the outsides as a solution. right? Now, you may have some situations where you're dealing with things that are just absolutely impossible, right? And I'm talking about being logical. For instance, let's just go ahead and say the absolute value of x is greater than -3. And I want you to think about that. An absolute value is greater than a negative number. When is that going to happen? That's going to happen everywhere. So if we had done a number line and used, again, -3 and, oh wait, no, we don't even have to do that because we need to be logical, right? An absolute value is always going to be greater than any negative number. So here we would have all real numbers from -infinity to +infinity. Then if we think of it the other way, what if we're asking when is the absolute value less than -3? Well, when is an absolute value less than a negative number? It's never less than a negative number. So you're going to have no solution. So we have 4 general scenarios, right? We have a scenario logically that will always happen, -infinity to +infinity. We have a scenario logically that'll never happen, right? An absolute value is never less than a negative number, so that's no solution. And then we have times where your solution is either going to be the outside regions or the middle region, right? So those are our 4 different scenarios when we're dealing with absolute value inequalities.